Okay, welcome along to today's webinar entitled Occupational Noise, Hand-Arm Vibration and Whole Body Vibration. It's just gone 11 o'clock and we're going to start right away. Okay, just a quick introduction. My name is Diarmuid Keaney. My company is Acoustics. We're located at www.acoustics.ie. I hold an M.Sc in Applied Acoustics from the University of Derby, as well as that a Diploma in Acoustics and Noise Control, and a BE from the National University of Ireland. Just a quick introduction to some of our clients throughout Ireland. Now that we get that out of the way, moving on then. The objectives from today's webinar. Okay, I plan to provide you with an insight into occupational noise, hand-arm vibration and whole body vibration. As well as that, I'd like to introduce you to the relevant threshold values for noise, for hand-arm vibration and whole body vibration. And also I'd like to explain how we carry out a hand-arm vibration measurement. And as well as that, I also plan to show you how we carry out a whole body vibration measurement. Okay, so occupational noise and vibration. Well, this was originally set out in the Safety, Health and Welfare at Work Control of Noise at Work Regulations 2006. Now, this was then superseded by the following document. So basically, this replaced the 2007 we call it general application, replaced the 2006 work regulations. Particularly within that, there are two important parts that relate to this webinar. Part 5, Chapter 1 deals with the control of noise at work, and Part 5, Chapter 2 deals specifically with the control of vibration at work. So let's look at some of the health effects of noise. Well, deafness, we'll say the permanent loss of hearing arises from the continuous exposure to noise. And so this is a gradual process. So therefore, all of the controlling metrics, they use an 8-hour exposure limit and indeed a weekly exposure limit. So it's based on the assumption that over time, long-term exposure to noise or continuous exposure to noise will give rise to hearing damage. There's also another factor to be considered, which is blast deafness. This is the permanent loss of hearing arising out of sudden exposure to high noise levels that may produce greater damage to hearing. And again, when measuring noise, occupational noise, you measure two parameters. You look at the a parameter called the LAEQ, 8-hour value, as well as an LC peak, which is a maximum level. So it's almost like a peak level, and that is monitored as part of the assessment process. So a little quick note on those short duration events. An impulsive noise in excess of 150 dB would probably produce instantaneous damage, whereas noise in excess of 130 would be at the threshold of pain. So that's just to put those figures into context in relation to short-term events or noise events. Okay, looking at the general applications then that I spoke of in the last couple of slides, 2007 on noise, this sets out exposure limit values and exposure action values. Now, just to explain, during the daytime period, there is an exposure limit value. So it's based on an 8-hour exposure limit shall not exceed 87 dBA, and the peak, which is a C-weighted measurement, shall not exceed 140. Now, they are limit values. So in terms of your, say, for example, that you're specifying hearing protection, it must be designed to ensure that those limit values are not exceeded. And that's the basis of the exposure limit value. So it does consider the use of hearing protection if absolutely necessary. Obviously, we should always try to design noise environments that don't require the use of hearing protection, but in some cases it's not feasible to do that. But basically, there is a specific exposure limit value that we need to work within. Also, within the General Applications 2007 guidance, there are what are called upper exposure action values and lower exposure action values. So basically, depending on your noise climate and where it sits when examined or evaluated over an 8-hour period, you could fall within a lower action value, or you could fall within an upper action value. And in such cases, there is different requirements. A lower exposure action value, for example, is generally a lower noise environment. So there's a certain number of requirements required there for the employer. Whereas in upper exposure action values, there are generally more sort of stringent conditions stipulated. So essentially, there's just three things to take away from that slide. One, that there is an exposure limit value, there's an upper exposure action value, and again, a lower exposure action value. This is a very useful noise exposure calculator. It's produced by the Health and Safety Executive in the UK. And in there, you'll find there are very useful Excel sheets that can be used to determine, we'll say, somebody's daily noise exposure, or indeed their weekly noise exposure. So using measurements, once you've measured the noise source accurately using the proper instrumentation, you can work out, based on the number of hours spent, for example, on a specific machine, you can work out what their likely daily exposure level is, or indeed their weekly exposure level is. Now, there's also a useful Excel document there as well on hearing protection calculators, and that is based on measurements where you carry out an octave band measurement of the noise source, and using the hearing protection data, you can work out how much protection is likely to be offered by that hearing protection. So again, they use Excel, Microsoft Excel. We would advise you to be cautious in terms of using these figures. The Excel sheets are correct from what we are aware, but they always should be checked by somebody who's qualified to do so. Okay, so the measurement of occupational noise, there's two methods of doing it. It's a spot measurement technique, whereby a noise consultant will move around a facility and carry out measurements in close proximity to the ear, and that's termed the spot measurement method. There's also a method of using dose meters, which can give varying results. Dose meters are particularly useful if you are planning to monitor noise over very long periods of time. Dose meters, for example, are something that we would encourage most facilities to have so that they could build up historical data. You should keep in mind, however, dose meters can be subject to inaccuracies. For example, they become a measurement technique. They're carried around in the absence of any sort of supervisor, if you like. So they could be subject to, for example, they could be left in cloakrooms. You just don't know. They're an unattended measurement, so you're trying to determine the noise exposure, and you don't know much about where the employee has been, for example. So again, spot measurement technique would be favoured in terms of an operator being able to quantify what the employee was doing at that time, or the machine that was being used, and so on. So again, both techniques can be used. Spot measurement is, in our view, the most accurate. Dose meters can be used, but again, they're something that I think you should use on an ongoing basis, and I wouldn't rely on them solely. Okay, so we'll move on to the next slide then. So vibration. Well, vibration can affect individuals in two ways. The first way is that vibration generated in the hands and arms by powered hand tools. We refer to that as hand-arm vibration, or you'll see it written as HAV. The other vibration you need to be aware of is it's titled whole body vibration, and it's vibration passing through the body which is generated in site vehicles and agricultural vehicles, and that's known as whole body vibration. There's two types of vibration we're concerned with. So again, referring to the General Applications 2007 on hand-arm vibration and exposure limit values, that document specifies for hand-arm vibration, for example, the daily exposure limit value, standardized again to an 8-hour reference period, shall be 5 meters per second. Now that's a measurement of acceleration. It's vibration acceleration. And again, it is based on an 8-hour reference period, similar to noise. So for example, if you had a powered hand tool, you would be concerned with we'll call it the trigger on time. For example, if you take an individual using an orbital sander at a facility, it's unlikely that an operator, for example, will use that particular piece of equipment for 8 hours solid. You're talking about work breaks, rest periods, and so on. So again, it's based on the likely exposure over an 8-hour period, and in some cases that might be as low as 5 and 6 hours per day. So you need to keep that in mind. It's not. It relates to the on time of that equipment. So sometimes we would use for pneumatic tools, we use a trigger on time measurement device. So whenever the pneumatic tool is used, it commences the clock, if you like. So you can work out exactly what the on time for that machine was for a given operator over an 8-hour reference period. Now again, there are limit values, and the first item there we're looking at is item A, which is a daily exposure limit value. And you'll notice there are also, similar to noise, there are daily exposure action values. And again, you'll notice that the acceleration is lower for the action value. So as an employer, for example, you have certain requirements that you must carry out when you reach the action value. So it initiates action, or is a series of steps an employer must take in order to protect the welfare of the employee. And again, there are action values, and you'll notice that the exposure limit value that cannot be exceeded is that. Okay, so moving on then, looking at whole body vibration at this time, and back again to General Applications 2007, you'll notice this is very similar. It's again based on a daily exposure limit value, standardized to an 8-hour reference period, and it shall be 1.15 meters per second. And again, you'll notice that vibration level would be a lot lower than the hand-arm vibration acceleration values. And again, simply you're exposing the whole body, if you like, to this. So again, you'll notice that there are daily exposure limit values, and of course action values. So again, when you reach the action value, you'll generally reach an action value before you will the exposure limit value. There are certain requirements for the employer. So they're similar when you consider noise, hand-arm vibration, and whole body vibration. They're based very much on daily exposure limits and, of course, action values in terms of the requirements for the employer. Okay, so let's look at some typical vibration magnitudes. For hand-arm vibration, for example, a chainsaw typically generates 6 meters per second in terms of its acceleration. This is an example of a hand sander. It generates, again, a higher acceleration. Again, a hammer drill and so on, and a road breaker. That's where an operator would be using a pneumatic road or a hydraulic road breaker. Again, you'll notice the levels will be higher. So depending on the machine, the piece of equipment, and of course the task being carried out at that time, will influence the hand-arm vibration levels. Okay, so moving on then, let's look at some typical examples of whole body vibration. One that would be common to us all. If you think of a car, for example, again, if you were to measure the level when driving along on a typical road, you may you may come up with a figure something like that. But again, as I say, a typical road, you could, depending very much on the surfaces of the road, the vehicle and so on, um, those values will vary considerably. But these are just sort of examples of typical vibration magnitudes, just to put them into context for you. Okay, so moving on to the next slide. Here are some examples of tools that generate hand-arm vibration. Now this is an angle grinder, and you'll notice there are two handles on it. There's a handle here, and there's also a handle here. So this operator's arm, both hands, should I say, are exposed to hand-arm vibration. So in a case like this, we would measure the vibration magnitude on both handles. Now, just in relation to angle grinders and similar equipment like that, a lot of the leading manufacturers are putting a lot more design now into the actual handle and decoupling the handle from the machine, in that it's still obviously connected to the machine for control purposes, but there is vibration decoupling in there, all in the interest of obviously protecting the employee and reducing the exposure to hand-arm vibration. Here's another example. Again, this is a masonry drill. Well, it's got a breaking, like a chipping hammer almost on that. But in this particular application, I don't know if you can see that in the photograph, but here we have an accelerometer attached to the handle. So it's a small enough device, but you attach accelerometer onto the handle, and it's in some cases tie wrapped onto the handle, and the operator uses that machine, and that's when you carry out your hand-arm vibration measurement. Another example, would be a pneumatic rock breaker. Again, you're concerned about the man-machine interface, where the operator holds onto the machine, and that's generally where you'll place your accelerometers in terms of measuring the amount of hand-arm vibration. Okay, so more tools generate hand-arm vibration. This is a chainsaw. Again, you have a handle, an operator holds a handle here, and they're holding another handle back here. And again, each time that machine is used, will generate hand-arm vibration. This is an example of a particular piece of construction equipment. It's often called a whacker, if you like, used for leveling purposes. But that machine induces vibration into the handles, if you like. And here, again, we have an accelerometer attached onto the handles of that machine, if you like, and you can, this device, if you like, is carried by an operator while you're carrying out that measurement. It's just resting there at the minute for the purposes of the photograph. Okay, so common sources, again, the forestry sector. Would be, we call it a high-risk category. Another high-risk category would be those working in the aviation sector, or indeed in any sort of, if you've got body shop applications where you have operators using, orbital sanders, for example, for long periods of time. You can see that operator, for example, will have his hand over this pneumatic orbital sander. He may be doing that for 4, 5, 6, 7 hours a day. So again, they're getting lots of vibration induced into the hand and arm. Again, a lot of the manufacturers, this isn't an example of one, but again, you're always concerned with the handles. You're concerned where the operator holds the particular piece of equipment, and that's where you attach your accelerometers. Local authorities have a number of people in this type of an application where they're using these brush cutters, and again, they have their hands firmly on a machine that's mechanically connected, and there's a certain level of vibration that's induced into those handles all the time. Okay, so moving on to the next slide then, we're dealing specifically obviously with the measurement of hand-arm vibration. So this is one particular application where this vibrating device is used to get rid of air in concrete, if you like. But it vibrates, if you like, and it induces vibration up into the hand. So again, you'll notice there's an accelerometer attached here, for example, and a lead coming off that and back onto your device here, where you can measure the amount of hand-arm vibration. Now again, this accelerometer is close to the source. I would suggest it would be probably better at that point where the operator is holds that device, if you like. So again, you need to be very careful as to where they are placed, which is critical. So why are we concerned about hand-arm vibration? Well, workers that are affected by hand-arm vibration, they commonly report the following. They report attacks of whitening or blanching of one or more of the fingers when exposed to the cold. So this is an attack, we'll say, that comes on the hand. It's like a blanching effect that happens, but it only happens, or they start to notice it, if you like, when the hand becomes cold. Again, workers can report a tingling or a loss of sensation in their fingers. Also, some notes would suggest there's a loss of light touch. So the sensitivity of the hand can be affected by hand-arm vibration. Many will report pain and cold sensations between periodic white finger attacks. So again, it can cause pain, something to keep in mind. And another factor can be a loss of grip strength, where you lose your ability to hold something, and that would be in very severe cases. But these are all just known health effects. Now, I wouldn't be qualified to make any comment on health effects, but we do measure in accordance with the guidance values, and that's essentially, I suppose, our area of expertise. But again, the health effects, these are just known health effects that I'm reproducing here that might be of use. Okay, so again, the last one there is bone cysts in fingers and wrists. Again, it's not my specific area, so I won't go into it in much detail. This is what I understand are some of the symptoms of vibration white finger. Again, I understand that it's a sort of a blanching effect that you'll get on fingers. It's quite obvious in these photographs, but that is what I understand to be an example of vibration white finger. Okay, so again, like the noise earlier on, I explained that the health and safety executive in the UK they're quite progressive, and they provide some useful documentation on the control of and the risks of hand-arm vibration. They also provide a guide to using their hand-arm vibration calculator, and they have a calculator in Excel, again, where you can measure the vibration level of a given hand tool, for example, and work out based on the time on that machine what the daily and weekly exposure values are, and see where it sits in relation to the exposure levels, the limiting values, and indeed the exposure values and the limiting values for that day. Okay. So again, when you're measuring hand-arm vibration, it's important that you follow a standard, and the standard that's used for that is BS-EN ISO 5349. And again, going back to the specifics as to where the accelerometer should be placed, this standard sets out actual axes where you need to be measuring. You're measuring typically, you're measuring in 3 axes. In terms of your handle or the handle of the device that you're testing. Now, it is important to note that there is a weighting correction that is applied to these measurements. So the instrumentation that we use has a weighting correction, if you like. So it's a weighted acceleration. So it's like that while we use an accelerometer, we're not measuring the linear acceleration. We are measuring a weighted acceleration that has been corrected to represent how vibration affects, or the sensitivity of the hand and the hand and arm to vibration in certain axes. So again, what is important, it's a weighted acceleration. Again, we measure it on all handles, not just one handle. Any contact point, any human or man-machine interface point um, will need to be assessed. So it's two handles in the case of two equipment that's used with two hands. Again, we measure in all three orthogonal axes. Again, the standard does specify where they are. It gives you an X. An X, you'll notice, is in this direction. You'll have a Y, and then which is, we can't see it on this particular drawing, but and then you have a Z. So it specifies exactly where those axes are. You'll see the Y axis is along here. Okay, and again, what happens then is you take those measurements on the three axes. So the accelerometer that you use has to be able to measure on three separate axes, and then it takes that information, if you like, and it works out the vector sum of those three vibration levels into three axes, and that's how you determine your vibration level for the hand-arm assessment process. Okay, so a couple of control measures then for hand. Okay, so let's look at some control measures. We can carry out a risk assessment, we'll say, to evaluate the potential exposure of employees to hand-arm vibration. And that in its own right is a control measure. You can look at alternative methods to be used. For example, is what you're using, for example, is the method you're using the best method? Are there alternative methods? Does the process require the human interface, if you like? Is there another or a better way of doing it that can reduce the exposure to employees? The other thing that would be recommended is that you carry out pre-employment health assessments. That would be to determine if somebody already has had exposure to hand-arm vibration and may have symptoms already there that you should know about, and avoid, obviously, if somebody had exposure to this in the past, perhaps you wouldn't worsen the situation by exposing them to vibration on a daily basis. One other method is to introduce job rotation to minimize exposure. So if there is a particular job to be done, rotate employees so that their exposure time is minimized. Maybe, for example, in the event of an employee using an orbital sander, for example, that would be limited to, say, 2 hours a day and so on. Or for example, that it would be rotated between 2 or 3 employees, again minimizing the exposure by sharing it with, say, over 3 or 4 employees. Another important thing would be obviously to consult with tool manufacturers and suppliers, hire companies. Is it possible, for example, to source low vibration tools? As I said to you earlier on, a lot of the market leaders are developing improved technologies where the handles are, there's better decoupling between the tool and the actual handle. And in such cases, it reduces employee exposure to vibration. And again, as I say, treat manufacturers. This is an important note. You need to be careful when you see a machine advertised as a low vibration machine. In order to get that, it's not a classification, but it's something that a manufacturer may advertise. For example, a low vibration machine. This could be a low vibration of a machine of a prior machine that they had. So you need to really know what kind of vibration levels that they produce. So I would just advise you to treat manufacturers and hire companies' vibration ratings with a little bit of caution. It may be a lower vibration machine than a previous machine that they had, but it doesn't necessarily suggest that it's not going to cause damage or injury. So just keep that in mind. Some of the control measures then for hand-arm vibration. Check out databases. There are databases available where tools are giving a rating. Again, you need to be sure that the data available is relevant and accurate, but it is something that is emerging where they're starting to classify tools um, and specify makes and models and the likely vibration level. Now, keep in mind, it depends very much on what the tool is doing. For example, if you're using that hand tool to cut something that's rough and difficult, it might induce a much higher vibration level than if you were cutting something that was soft and easier to machine. So again, there can be variation in the process, so you need to be mindful of that as well. The other thing is obviously to brief all employees on the risk and dangers associated with hand-arm vibration, which will be important. And it is also suggested in the guidance that you would initiate weekly skin checks. That is a detailed, we'll say, control measure. And again, as with any sort of health risks, it does recommend that you would introduce periodic health surveillance checks as well. One thing that is important would be when people are using vibrating equipment would be to keep the hands warm and to maintain circulation. So in some cases where there is a lot of vibration, even though gloves are not that effective in terms of reducing vibration, they do keep the hands warm and they do maintain circulation. And again, these are all guidance or control measures that are suggested in the guidance documents, and not something that we've put together, but I'm just reproducing them here so that you have a record of them. Okay, so moving on then to whole body vibration. Well, these are examples of machines or equipment that can give rise to whole body vibration. Again, this is a vibratory roller where you may have an operator sitting on that machine for long periods of time throughout a day. That machine in its own right, while it rolls, it also vibrates. And as a result, you can have an operator sitting on the machine and vibration will be induced into the feet and into that operator. So again, an operator can be exposed to whole body vibration on a machine like that. Again, forestry equipment, you could have an operator inside that cab that's exposed to vibration throughout a day. This is a more common example. Local authorities may have employees on the likes of gardening equipment, but you could have an operator sitting on a machine like that for 6 hours a day, so with something, I suppose, grass cutting, if you like, and as a result, there's vibration being induced into the body throughout the day as they carry out the work. And another good example would be buses. Some of these older buses used by Dublin Bus, they may not have, I'm not suggesting that the Dublin Bus don't have, but it's something to keep in mind that perhaps whole body vibration should be considered in relation to the types of seats provided in these for drivers that are, doing a lot of city driving, if you like, sometimes on quite rough street surfaces, and you get vibration induced into the body. So again, it's something that should be checked and monitored. And then, of course, forklift drivers. Again, you could have somebody in a warehouse, moving equipment, sitting in a machine like that all day, exposed to vibration, depending very much on the surface, of course, and the likely work carried out. Okay, so again, some health effects of chronic vibration. Lower back pain, for example, can be caused by whole body vibration or lots of exposure to whole body vibration. You can also get neck and shoulder disorders arising from long-term exposure to whole body vibration. You can also get digestive and circulatory disorders. And these, again, as I said, these are within all the guidance documents. These are what they suggest are the health effects. Others are, we'll say, insomnia, headaches, shakiness shortly after or during exposure. And these are just something, that's information that we have taken from guidance documents in terms of the reported effects of, we'll say, chronic vibration. Okay, so going on to the measurement then of whole body vibration. Well, this is our equipment in place in a bus, for example. And again, We're measuring in specific axes. Inside in this device is an accelerometer, and it's measuring vertically, and horizontally, and there's the X and the Y direction, and the Z direction is vertically. So again, when you're measuring that, there is the instrumentation has weightings applied to all of these axes. So it corrects for the human body's susceptibility to vibration, for example, in the vertical, as opposed to the horizontal, those the X and the Y axis. So that is important, and it's an important element of the measurement process. Again, this is a lower part of that seat. So if you can imagine, as that bus, if you like, travels, we'll say, or throughout the city, the floor, the base of the bus is vibrating and inducing that up through that post, if you like. So the driver is getting a certain amount of vertical vibration, and of course he's getting vibration in the X and the Y axis as well. So when we're measuring it then, this is some of the instrumentation that we would use to measure it. The instrument will report back to us the measurement in the X-axis, the Y-axis, and the Z-axis, and it works out vibration levels, again based on the vector sum I discussed earlier on, but it'll work that out for the operator, and it's something that you would measure over a period of time. So you're interested in the operator's exposure throughout a daytime period, but you need to take sort of representative samples, and in this particular example, you're only 43 minutes into the measurement. So again, it needs to be representative of what the operator is likely to be exposed to. Again, the Health Service and Safety Executive in the UK have provided very good guidance on this, and as well as that, they also have vibration calculators. The Health and Safety Authority in Ireland also have some information in terms of the General Applications Regulations of 2007, and again is that Chapter 2 of Part 5 deals specifically with the control of vibration at work. That's a useful document. So again, good opportunity for the Health and Safety Authority here in Ireland would be to provide some more information, I think, on hand-arm vibration and whole body vibration. There is a limited amount of information available when you compare it with what's available in the UK, but that's something that I think will come in time. One thing to keep in mind, we note in the UK that there are legal companies specializing in hand-arm vibration claims. This is an example of one such solicitors. They offer this as a specialist service. They deal with all sorts of claims, if you like, but this is an example of one that deals specifically with hand-arm vibration. Again, in terms of hand-arm vibration, there is a method called the Stockholm Scale that deals with the severity of a hand-arm vibration claim, depending on how bad the effect is, or if you're suffering, for example, from blanching in the fingers, you can quantify and calculate the severity of the damage using this Stockholm scale. So I just said I'd mention it. There is I suppose, a recognized method of determining how bad or how affected you are by hand-arm vibration. Okay, so moving on then, there is also companies that specialize, of course, in whole body vibration claims. Again, this particular legal firm says, whole body vibration syndrome. So they talk about this in detail. They have a speciality in this area, and again, this is something that's fairly widespread in the UK. Not so much here, but it's certainly something to consider. Okay, so the next steps, we have two very good guidance documents from the UK on hand-arm vibration and on whole body vibration. And if you'd like a copy of those, if you just email me at diarmuid@acoustics.ie. And of course, if you have any project specifically that you'd like us to look at, please feel free to get in touch. Okay, so that it almost concludes it. Just some successful hand-arm vibration claims in the UK. I'll just deal with these very quickly. British Gas fitter got a compensation of 143,000 in terms of one hand-arm vibration claim. Here is another example. There was a claim for £200,000 to a tree surgeon employed by Liverpool City Council, which was another successful hand-arm vibration claim. So I just put up a couple of examples of different cases there, which I think are important in that this is something that needs to be addressed, and there's a facility there to carry out risk assessments, to measure, to quantify it, and to make recommendation if action needs to be taken, and which would certainly avoid claims here in Ireland and indeed in the UK and on a worldwide basis also. Okay, so also there's plenty of examples of whole body vibration claims. I just took this one, for example, where 1.9 million was awarded to a train driver for whole body vibration. And that's another high risk activity, if you like, where you might have, a train driver standing for long periods of time or indeed seated. So you can measure the exposure to vibration in the standing or in the seated arrangement. So it is an important factor. So thank you for your time. As I say, my contact details, I'll leave them on screen there. And if you have any questions, please feel free to text them through and I'll try and answer them for you. Thank you for your time.